We're going to look at an introduction to statistics today, specifically focusing on measures of central tendency, measures of dispersion, and some other attributes of this. So, a measure of central tendency is a number used to represent a typical number in the data set. The mean is our average of our values, which means I'll sum up my values and divide by the number of total values. The median is the middle number of the values. If there's an odd, it's just that number. But if there's an even, it's the average of the two middle. Or even number of values. Odd or even values. The values are odd versus even. Like the number of values. The mode is the most often. It is possible for data sets to have no mode or one mode or two modes. So if I take a look at this data, I've got 15, 16, 18, 19, 20, 25, 36, 25, 17, 14, 15, 23, 15, 20, 17, 32, 35, 31, 5. What you notice right off the bat with these values is that they are not in ascending order. Now, you could go through and put them in ascending order and be like, the first number's 5, then the next one looks like it's 14, and go from there. But I want to show you a trick with the calculator that allows us to do that. So if I put this data into L1, I can actually have the calculator sort it for me. So okay. All right, there we go. All right, so I'm going to hit Stat, and I'm going to go into Edit, and under Edit, I'm going to clear out anything that might be in L1 or L2 already, and I'm going to start by doing in L1 my numbers. So 6, 15, 16, 18. We want to be really careful as I type in here, and the reason I want to be so careful is because if I type one in wrong, it's going to, or I miss one, it's going to give me a lot of wrong answers for the rest of this. So we're typing them in very carefully. Sometimes after I type them in, I will double check them backwards. So I'll start at the end and then go forwards from there to try and just check in a slightly different way than I typed them in. So going from there, 32, 35, 31, and then 5. All right, so I'm going to go Stat, and then sorta, that A is standing for ascending, so it's going to sort the values in ascending order. And then I want to tell it what I want to sort. I want to sort L1. To do L1, I'm going to do second and then 1. You can see L1 is written over the 1 button in blue, and blue means it's the second button first. So I hit Enter, and it tells me it's done, and then I can either do that second one again to see L1 there and scroll through, or I can go back to Stat Edit and scroll through here. But either way, they're in ascending order for me now. Okay. Oops. Okay. So L1 looks like 5, 14, 15, 15. So 16, 17, 18, 19, 20, 20, 23, 25, 2 25s, 31, 32, 35, 36. I'm just going over 35, 36. Awesome. So we want to know the mean, So the symbol we use to represent mean is this X bar, okay? And that means I'm going to add up all of these values. 5 plus 14 plus 15 plus 15. There's 3 15s. 16 and 17, 17, 18, 19, 20, 23, 25, 25, and 31, 32, 35, 36. And for those wondering if there's a faster way, there is. I'll show it to you in a little bit. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 values. So we're going to divide by 19. So we get this is 20.947. So I'm going to round to 3 decimal places. So a lot of times when you did median in the past, you would just kind of cross them off. Anybody do this when you did stats? One at a time once they're in order. And then you can see my median is 19. And then my mode here is 15 because there was 3 of them. Now, some other things that we might not know is our first quartile and our third quartile. Now, second quartile is a new name for something we already know. It's another name for our median. Now, first quartile wants me to find the median of this lower half of my data. So this is my data of only half of my data. Notice I exclude 19 rather. Sorry, I'm writing 16 and saying 19. I'm excluding that 19 because it's the median. So it's not in either half. So in this problem, my first quartile would be 15. Then when I do my third quartile, I'll take the upper half and I'll do the same thing again. And I want to find. Now our quartiles are part of what we describe as our 5-number summary. So in this problem, we'd say our median is 19, our first quartile is 15, and our third quartile is 25 for those. We also have our mean, and our mode was 15. Now, a measure of dispersion is a number used to describe how spread the scores in a distribution are. So for our range, we do our largest minus our smallest. So when we talk about that, our largest value here was 36, and our smallest was 5. So this would be 36 minus 5, which is 11 for our range. This is not to be confused with range of a function where it's an interval. This range is solely a single value. IQR is described as that's the interquartile range. And that interquartile range is really just Q3 minus Q1. So in that problem, our Q3 was 25 and our Q1 was 15. So the interquartile range is 10. So we're going to work with something called a 5-number summary. And the 5-number summary is talking about the min, the quartiles, the median, and the max. And quartiles being the first quartile and the third quartile. So let's take this. It's how long will your homework take you in minutes? So we're going to go a slightly faster way on this. And I want you to take that data and put it all into L1. Go ahead and pause the video while you do that. Once your data is all in L1, what we're going to do is we're going to hit Stat, and this time we're going to head over to Calc and click that first option where it says 1-bar stats. That first option, my screen looks a little different because I have an older calculator, but your screen probably will match with the buttons on your handout. So we hit Enter, and it gives us this. Now, the first thing I notice here on the first half of our 1-bar stats is it tells me the X bar. Now that's not part of our 5-number summary, but that mean is really kind of handy to find. So 28 points on average is taking people 20.812 minutes for their homework. It's not part of their 5-number summary though. Now if I hit down, you can see I've got more stuff on the bottom there. There's our 5-number summary. So I have a minimum of 0. I have a first quartile of 16. I have a median of 21.5. I have a third quartile of 26. And I have a max of 41. Okay, so there's our 5-number summary. Now, in the past, you've kind of found an outlier by kind of inspection and looking at it and saying which one of these doesn't belong. So an outlier is a data point that is distinctly separate from the rest of the data, in case you forgot. And you might think that one of these doesn't fit with the others. Now, mathematically, one definition of an outlier, and it's not the only definition, but one commonly used definition is it's an outlier if it's more than 1.5 times the interquartile range below the first quartile or above the third quartile. Now, again, this is a widely used one, but not the end-all be-all of outliers. Now, let's figure out our IQR here. Our IQR, interquartile range, that's going to be the third quartile minus the first quartile, which is 26 minus 16, and which is 10. Now, if I do 1.5 times that value, that's going to be 15. So any value that is 15 smaller than 16, that's our first quartile, okay, or 15 more than 26 will be considered an outlier. So 26 plus 15 actually gives me that 41. So the 41 or higher would be an outlier. So this one is an outlier. And on the other side, 16 minus 15 is 1. So 0 actually is an outlier as well. This problem had 2 different outliers. So our IQR was 10, and our outliers, both 0 and 41, are considered outliers by this definition. So percentile, the most common place you probably have heard the word percentile is at the doctor's office. So when you go for your yearly checkup, they might tell you what percentile you are for height, what percentile you are for weight. And they've done that since the very beginning. Your first checkup at the doctor, they've probably told you that. So to find the percentile, you find the number of values that are below that value, divided by the total number of values, and multiply by 100, and that gives you your percentile. So first thing I want to do is I want to put these in order because they're not in order. I've got 2, 3, 5. Now, if you struggle with putting these in order in the past, you can use that sort A feature that I showcased. Okay, there's nothing wrong with that. 15. I like that one kid got a 23. I wonder if there was a bonus. All right, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, all 10 are there. Now, the percentile rank of a score of 12. Well, 12 isn't on this list. Let's change that. We're going to make it a score of 10 because that's one of our values. So here's 10. Okay, now how many values are below it? Well, 1, 2, 3, 4, 5. So 10 is the 50th percentile. Okay. Go ahead and try example 4 on your own. Find the values of the 30th and the 60th percentile for the data. Remember, you want to order the numbers, then we have to figure out how many numbers I have, and 30% of those numbers should be smaller than that 30th percentile, and 60% should be strictly smaller than that percentile. Okay. All right, we'll follow up with that one in class. Okay, but I do want you to try that right now. Now, Our standard deviation is a measure of how much the values in a data set vary. It's represented with a lowercase sigma. Look at that, lovely. It looks like O with a ponytail. And it's kind of a long process. We're only going to do it once by hand just so that you can see what's happening. And after that, we won't do them by hand. So the first step you do is you find the mean, then you find the difference between each value in the mean, and you square those, you take the average of those squares, and then you square root those averages. If the standard deviation is low, then the values are clustered together. If the standard deviation is high, the values or the data points are more spread apart. Variance is the average of those squared differences from the mean. It's denoted either with a sigma squared or sometimes you see var x. All right, so we have, I guess, maybe some test scores or something here, and we want to find the standard deviation. So first thing I need to do is I need to find the mean of these test scores. I'm going to add them all up and divide by 5. So I add them all up and divide by 5 to get a mean of 91. So the mean is the same all the way through. So then in this spot we have 78.2 minus 91, and that is negative 12.8. And when I square that, I'm going to get 163.84. And then I'm going to do 90.5 minus the 91. It's going to be negative 0.5. And then I square it to get 0.25. Then 98.1 minus the 91, 77.1. And then I square it. You can see how the ones that are further away have these larger numbers. That's creating our standard deviation to be a larger number, which is why the standard deviation, when that is high, it tells me my values are really spread. 2.7, and that's going to be 7.2, and 94.5 minus that 91, and 12.25. Okay. All right, so now I'm going to add these all up. 163.84 plus 0.25 plus 50.41 plus 7.29 plus 12.2. All right, divide by 5, 230. And 46.808. So this would be our variance. And that means our standard deviation is going to be the square root of that, which is square root of that 6.842. 6.842. You can actually still find this under that same spot with that one variable statistics. Let's go back there for a sec. Okay, stat, over to calc. And actually, I'm going to put this data in. One thing to be careful of, when you delete the data, I go up and I hit clear on L1, but if you hit delete, you're going to lose your L1. So not a big deal, you can get it back, but it's not something you want to do. You can either delete individual entries or you can hit clear on the whole thing. Don't hit delete on the whole thing. All right, so I'm putting these in. And then we're going to go stat over to calc with that one variable statistics. You can see that mean of 91 that we had. And look at that. I'm going to make it a little bigger because I can't see it. So here's that mean. Oops, try again. And my standard deviation right there. Okay, with our lowercase sigma. Okay, go ahead and find the standard deviation of these ones. Okay, go ahead and put those into your calculator and find the standard deviation. Okay, well, again, we'll go over that again in class. Now we're going to take a look at example 7. The number of points darted and scored in each of 11 basketball games is listed below. Within how many standard deviations do the values fall? So I'm going to start by clearing it out. I'm going to hit enter. I'm going to put in all my data. So 8, and then 12, and then 13, and then 10, 7, 5, 10, 9, 13, 11, and 8. So we hit stat, over to calc, one variable statistics. Okay. So I need 2 pieces from this time. I need both the mean and the standard deviation. Okay. So our mean here is 9.636, and we have a standard deviation of 2.422. Okay. So let's find I'm also going to go down and say my lowest is 5 and the highest was 13. So I'm just going to highlight them because these were not in order. Okay. So if I do my 9.636, and I subtract that standard deviation, one standard deviation away would be 7.214. Another one below would be 4.792. And our data point of 5 would be right there. You can see that's within 1, 2 standard deviations below. When I go above 9.636 plus 2.422, it's going to be 12.058. Then if I add another 2.422, I'm going to get up to 14.48. Now, our highest value on this was 13, which is going to be in between these, right there. So we would say that this is within 2 standard deviations because 2 standard deviations above or below. Okay. Go ahead and do example 8 on your own. Okay. So again, we're going to find all of these standard deviations. So you're doing 8 on your own. Go ahead and pause the video. And again, we'll go over those again in class. All right. Did you do example 8? Are you sure? Okay. A sample gathers information from only a part of the population. The sample proportion is x over n, where x is the number of times the event occurs in a sample space of n. So in a sample of 500 teenagers, 328 had never attended a popular concert. Find the sample proportion for those who'd never attended a popular concert. So 328 divided by 500. And then I do that out and you can write it as either 82 over 125 for a fraction, or you could say 65.6%. I tend on these to write the percentage. So sample theory is a branch of statistics that deals with questions that arise whenever a sample is taken. We've got a couple of different sampling methods outlined here. So a simple random sample is each individual in the population has an equal chance of being selected. Self-selected samples are individuals who are volunteer to be part of a sample. I call that like the Yelp effect. It's people go on Yelp to make an opinion and voice their opinions. Convenience sample. Individuals are selected based on how accessible they are. So that happens in a situation when you survey people standing in like one location. If you're going to survey just people at the library. Systematic sample. Members of the sample are chosen according to a rule, such as every individual in the population. So it's like list everybody alphabetically, and I want every 10th person. Okay. Stratified sample, is when I take a population and divide it into groups, and individuals from each group are selected, typically through some sort of random sampling within that group. So that would be like a stratified sample would be like, I want to survey 40 people at the school, but I want to make sure I have 10 freshmen, 10 sophomores, 10 juniors, and 10 seniors because I want to make sure that I have equal representation over the grades. A cluster sample is when the population is divided into groups. Some groups are randomly selected and either all the individuals in the selected group are selected or just some of them are from there. So again, some sort of random process even within there. So let's see. Viewers are invited to call a TV program and express their opinions. This sample may have overrepresented or underrepresented some views. This is called a self-selected survey because people had to reach out and call in. They surveyed people on the street near the high school. We have some convenience bias. Convenience sample. Okay. It's convenient for the reporter to stay in one place since by the school, students or teachers are overrepresented. How many people we survey is going to affect our reliability. So there's lots of ways to measure what the error would be. So margin of error is the estimate of error in any sample. The measure we're going to look at is plus or minus 1 over the square root of n. There are other ones as well that might give you within a certain confidence as well. If you go deeper into statistics, you'll see more versions of this. An opinion poll about the popularity of the town selectmen has a margin of error of 5%. Estimate the number of people surveyed. So that means 1 over the square root of n has to give me 0.05. I just lost my plus or minuses because if I have a plus or minus on this and a plus or minus on that, I don't need it on both. So I'm going to have 1 over 0.05 square root of n. And now I'm just solving for n. The good news is we solved the radical equations early in the year, so we have no problem finding that n is 400. A survey found that 78% of people were happy with the town selectmen. Use the margin of error to find an interval that is likely to contain the true population. Well, if 78% are happy, according to their survey, but we have a margin of error of 5%, that means somewhere between 73% and 83% is likely to contain that value. Okay, because I just took that 78% and I added and subtracted 5% from it. Go ahead and try the last example, example 14. Okay, again, I will take a look at those answers in class. Okay, this concludes our lesson. Go ahead and finish up that delta math.